Hello, my dear mechanical as well as civil aspirants. How are you all? What's up? कैसे हैं सब लोग? Please जल्दी जल्दी आ जाइए and do let me know if my audio and video are perfectly fine so that we can start our session at the earliest. Those guys who are watching me live, please respond through the comment section to let me know whether my audio video are clear or not, so that we can rectify the issue before starting the session. Fine. Hi Mithun, good evening, welcome. How was your day? कैसा रहा आपका दिन? Anything new today? So this is Chandrasekhar welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S Exam Prep. And you guys are watching me live through the beautiful series, very important series for mechanical and civil gate 2023 aspirants. All right, how is COVID situation in your area? So this free session is very beneficial for those who are preparing for gate 23 examination, because we are giving you the concept clarity as well as the numerical practice session, and there will be a quiz at the end of this subject, fluid mechanics, to check your understanding about the whole subject. So that is why I want everyone to be part of this series every alternate day, that is Monday, Wednesday, Friday and Sunday, every alternate day at 8 p.m. on the BYJU'S YouTube channel. All right. Hi Ranbir. Good evening. Good evening, guys. Please respond. I want everyone to be part of this session or to communicate with me more and more. और आज का जो discussion है, that is all about practicing the numericals for manometry. I hope you guys are already comfortable with the Pascal law and hydrostatic law, which I had discussed in the previous class. If you have not attended that class, you can watch the recording by searching the series gate 2023, and you can watch Pascal law and hydrostatic law and pressure equation concept. All right. Hi Susoban. Oh wow, Susoban had started implementing the fluid mechanics concept in real life. Very nice. Hi Amin. Good evening. Namaskar. Adab. Shubh Sandhya. Good evening. Sat Sri Akal. Assalamu alaikum. Vanakkam. So please keep your pen, paper and calculator handy so that you will be taking part in the session in solving the numericals, because practicing is one thing which is very important for understanding the concept of the subject. If you do not practice, you do not deserve to win in your competitive examination. All right, I mean, the concept session was day before yesterday, and today is the practice session, and through the numericals also you will be able to understand the concept. Only two concepts are very important in understanding the whole manometry. One is the Pascal law, another is the hydrostatic law. Both these concepts, beautiful concepts of fluid statics, are the backbone of the topic, and the topic fluid statics is most important in the fluid mechanics for your competitive examination. All right, this is my entire schedule. You can take the screenshot for the fluid mechanics. This is my sessions I have planned for the fluid mechanics, and the timing is definitely 8 p.m. on Monday, Wednesday, Friday and Sunday. And the series, this subject will continue till 29th, and 29th get yourself ready for the Menti quiz for fluid mechanics and strength of materials. I am always very curious to know how many of you are civil engineers. कितने लोग civil branch से हैं? Anybody here from civil background? Please do let me know. Mechanical engineers already know about me. Civil के कितने लोग हैं? I want civil students also to be part of this series, because fluid mechanics is common for mechanical as well as civil aspirants. So they also get benefited. Hi Rajesh, good evening, welcome. Please keep on talking to me. How is the weather in your area? How is uh, the COVID situation in your area? How you are? Where do you located yourself? Please keep on letting me know your location and anything else which you want to share. There is a comment box available to talk to me through the comment section. This is my introduction. I hope you guys are already familiar about me. Fluid mechanics is one of the in Delhi. Why I am asking about the COVID situation, because in Delhi NCR the cases have started increasing. So you guys should also be very cautious about your health. Otherwise, there is a high possibility of having the COVID fourth wave very soon. Yes, Setupati, good to see. This is my contact details. You can always contact me through the mail ID which is there on the screen. Hot weather in AP, okay. Right. Yes. And you can also join me on the Telegram. Those who are not part of my Telegram group, I would strongly recommend to be part of my Telegram group, Mechanical by Chandrasekhar sir. And there is a link mentioned over the screen over here. So keep your pen, paper and calculator along with you, so that you will be in a position. If anybody is having any doubt in theoretical portion, you just let me know before starting the session, so that I will rectify your doubts and you will be able to perform very well in the quiz. It is kind of quiz. Yes, Rajesh, but very soon the COVID restrictions will again be implemented, because in Delhi NCR the situations is getting worse day by day. Other than the free sessions which we are providing to the students, there are paid courses also running on the BYJU'S exam prep. You can be part of our paid courses, so you will get more guidance in the right direction with our experience, and we will provide you the live classes along with the study notes. Everything will be provided by us if you become part of our paid course, and the chances for you to get the selection increases multifold. You can see there earlier also we have proved ourselves by producing all India rank 1, 2 as well as 3. Hi Arun, what's up? Message को delete कर दिया. And do not forget to like, share and the subscribing the channel so that it reaches to maximum audience. किसी ने बताया नहीं? Anyone here from civil engineering background? Anyone here from civil? So let us start without wasting much time. I hope everyone, those who want to be part of this session, have already joined me. Shall we start? Please make some noise. Are you guys ready for the action? The questions will be from Manometry and there will be MCQs as well as MSQs also. The questions will be very simple. There will be theoretical conceptual question also. Along with that, there will be around 10 to 11 questions I have brought. Around 10 to 11 questions will be there. And please observe your performance so that you can improve yourself further in the next quiz, and you can improve your concept to get the best possible rank and best possible marks in your examination. I hope everyone is already charged up to explore this. As always, I ask you very simple basic question before I start the session to check your understanding about the subject. Hi Bhavya, yes, there is a question on the screen. In the static fluid, the variation of pressure is linear with depth. Is the statement correct or false? Is it yes or no? So Soban, ye yes kiske liye? Is that for answer or for being charged up? In the static fluid, the pressure variation, it is about the hydrostatic law, if I am not wrong. Do you know the hydrostatic law? The statement is correct or incorrect? I want everyone to be part of this question. Oh my God. Ranveer had said no. Why not? Ranveer, what should be the answer then? Why? Why? If your answer is no, my next question will be why. But if your answer will be yes, then the discussion ends here only. Tell me. Only Ranveer had given the correct answer, that is no. In the static fluid, the pressure variation is not always linear. It is linear for incompressible fluid. Do you guys remember it or not? It is in linear for incompressible fluid only. When we talk about a fluid, it can be compressible as well as it can be incompressible, isn't it? For incompressible, it is linear. What is incompressible fluid? When the density is constant. But the variation is exponential if the fluid is compressible when rho is not constant. So for incompressible fluid, it will be linear, but for compressible fluid, the nature will not be linear, but it will be exponential. So the correct answer is no. It is the statement is not completely correct. The statement is only correct for incompressible fluid. So this was the assignment question I had given you. Did you guys try this question? What is the answer to this assignment question? ये क्वेश्चन किया आप लोगों ने? I want everyone to do the assignment question with your full dedication and religiously, because the assignment questions are very important for giving you the independent thought process, for developing the independent thought process and applying the concept. So it is very important. What is the answer to the question? Yes, Ananya, in Delhi NCR, they have started increasing. That is why I want everyone to, earlier the mask was not compulsory, but recently the Delhi NCR government had started applying this rule to put on mask when you go out. In Delhi NCR, the situation is becoming bad, but in the other part of the of India, the situation is not that bad as of now. But yes, precaution is always better than cure. So the answer to the question is 3. It is not 9, Varun. Capital H by small h will be 3. The answer will be 3. How the answer will be 3? Let us discuss this question. Let us first discuss this question and then we will move. Those who are getting the answer as those who are getting the answer 9, they are actually am I? I'm not able to. Those who are getting the answer 9, they are thinking that the fluid in the piezometer is having density rho, but it is actually 3 rho. This is the fluid which is entering into the piezometer. What is the piezometer? What is the piezometer? Yes, Ananya. So your studies should not get impacted. That is why you should also start preparing through online classes. There is a higher chance that the lockdown can also be there in the near future. So do not hamper your studies. Do become the part of the online platform so that your preparations should continue even if there is a lockdown. What is the piezometer? Anybody having any idea about the piezometer? Piezometer क्या होता है? There is a word mentioned that there is a piezometer. What do you know about a piezometer? Piezometer is one of the simplest instrument of measuring the pressure. How the piezometer works? It is an open-ended tube. Piezometer is an open-ended tube. like this, open from both the ends. It is an open-ended tube. Pressure measuring instrument, very correct, Bharat. But how it works, it is an open-ended tube and one end of the piezometer is inserted to the pipe where we want to measure the static pressure. And the attachment of the piezometer should be normal to the flow. That is very, very important. How many of you guys know about the attachment of the piezometer? The piezometer or YouTube manometer should always be attached normal to the flow. Why it is normal? It is attached normal to the flow. If there is a pipe in which the fluid is flowing, so piezometer can either be attached this way or it can be attached this way. Either this is another arrangement. It is always kept perpendicular to the flow because it is used to measure the static pressure. So velocity of the flow should not impact its measurement. That is why the attachment of the piezometer or YouTube manometer, any type of manometer, should always be kept normal to the flow. I hope it is clear. So let us move to the pressure equation by using the Pascal law and hydrostatic law. First of all, you need to find out the points which are having same pressure, according to Pascal law. According to Pascal law, the point should be lying in the static fluid, should be part of the static fluid. The point must be lying in the horizontal line and they must be joined by the continuous mass of same static fluid. Then if these three conditions are satisfied, then the pressure at those points will be same. Px is equal to Py. Continuous mass is very, very important. Px will be equal to Py, isn't it? So how to write Px? Start from the top. There is a atmospheric pressure. Here there is atmospheric pressure. So P atm is the pressure at the top of the tank or the container. Now apply the hydrostatic law. If we are moving in downward direction, the pressure always increases with depth. And we are moving in rho fluid, density rho into G into we are traveling at a distance 3h. We are here. Now we can further move in downward direction plus. Now we are traveling in 2 rho fluid. You need to take care in which fluid we are traveling. 2 rho into G into the distance traveled in that fluid is 1.5h. We are here now. We need to reach to X. Then we are further moving in downward direction, then plus. Now we are traveling in 3 rho fluid into G into H. This represents the pressure at X and should be equal to pressure at Y. How to write the pressure at Y? To write the pressure equation for the piezometer. At the top of the piezometer, because it is an open-ended tube, it is the atmospheric pressure. And because we are traveling in downward direction to reach at point Y, so plus. Now we are traveling in the fluid which is having the density 3 rho into G into capital H, and this represents Py. The equation I have written by using the datum line method. This is the datum line method. You could have used the jumping method also. You will get the same result. So look, you could have found out that these 2 points will also have the same pressure, isn't it? This is, let us say, point A. And you take the point B here because point A and B are also part of the static fluid. Point A and B are lying in the same horizontal plane and point A and B are joined by the continuous mass as well. Isn't it? Same 3 rho fluid is joining these 2 points A and B. So if I write using the jumping method, let me write. Somebody told me, so Soban had told yesterday, day before yesterday, that jumping method is more simpler compared to datum line method, but I don't think so. Both the methods are equally simple. It is only your notion, or it is only your thinking, wrong notion that you think that one is better, one is not, another is not. Start from the top of the left limb or the tank. P atm is the pressure at the top. We are moving in downward direction, rho into G into 3h. Plus we are moving in 2 rho fluid, 2 rho into G into 1.5h. Then we can jump from here to here, isn't it? Because the points are having the same pressure. So from A to B we can jump, and the pressure at A is equal to pressure at B. Now we are at B. and now we need to reach at the top of the piezometer because we know the pressure there. So because we are moving in upward direction, minus, now we are traveling in 3-row fluid into G into we are traveling only this distance. How much is that? Isn't it capital H minus small h? So into capital H minus small h is equal to our destination is the top of the piezometer, and the pressure at the top of the piezometer is galatfahmi. So PATM getting cancelled out, and you can find out the ratio of capital H by small h, that is 3. Alright, I hope it is clear. चलिए आगे बढ़े. Let us start our journey of questionnaire. First question, very simple question on the screen. Now it is your turn. Anybody is having anything to ask, you can just let me know through the comment section. Otherwise, give me the answer for this question. Which one of the following pressure units represent the least pressure? Which one of the following is having the minimum pressure? Which is the unit of minimum pressure? So whenever you are having the pressure in different units, what you need to do is convert all the pressure in a single unit, then only you can compare. Apple can only be compared with apples. Apple cannot be compared with bananas. तुक्का मार रहे हो? भाव्य, Bharat, Rajesh, Setupati, A, Ranbir, B. What about others? Let us convert it into Pascal. Can you write the increasing order, which is maximum? Mithun, D is minimum. Let us see if you are correct or not. If I talk about millibar, let me call it as 1 millibar. 1 millibar is equal to 10 to the power minus 3 bar. Or we can say 10 to the power minus 3 into 10 to the power 5 Pascal. Isn't it? Isn't it? Or can we say that is equal to 100 Pascal? Isn't it? 1 millibar is 100 Pascal. Do you guys agree or not? And 1 millimeter of Hg, that is in terms of pressure head of mercury. So 1 millimeter of mercury is density of mercury 13.6 into 10 to the power 3. That is the density. 13.6 into 10 to the power 3 or 13,600 into G. Let me take G as 10 into H, that is 1 mm, that is 10 to the power minus 3 meter. That much is the Pascal. So it is around 136 Pascal. Isn't it? 1 Newton per millimeter square. Do you know? So it is 1 by 10 to the power minus 2, 10 to the power minus 3 square. What is 1 millimeter? Yes, can you find it out? 1 by 10 to the power minus 3 whole square, or we can say it is 10 to the power 6 Pascal, or we can say it is 1 megapascal. 1 Newton per mm square is 1 megapascal, which we frequently use in our strength of materials. In SOM, we use Newton per meter square frequently, 10 to the power 6 Pascal, isn't it? And kgf per centimeter square, I had given you the conversion for this. 1 kgf is 9.81 Newton, or it is around 10 Newton. 1 centimeter is 10 to the power minus 2 square. So it is 10 into 10 to the power 4 Pascal, isn't it? Or we can say it is 10 to the power 5 Pascal. So this is how we can convert. So the minimum is A, then it is B, and then it is D, and the maximum is C, isn't it? Do you guys agree or not? So the answer to the question is A. Option A is the minimum. Millibar, definitely. चलिए आगे बढ़ते हैं. Let us move to the next one. Very simple question again. The question is from the Pascal law. Hydraulic press is based on the concept of Pascal law. I hope you are comfortable with the Pascal law. Please give it a try. Don't be afraid of committing mistakes. Because the more you commit mistake, the more you learn from your own mistakes. Nobody can teach you better than your own mistakes. और किसी को कोई डाउट है? कोई confusion है? Anything to be asked in your technical or the conceptual clarity, you can just let me know through the comment section. But I want everyone to give me the answer. Setupati, very nice. Setupati was the first one to get the answer. You need to take care of the time also. Time management is equally important. Try to be as fast as possible, but not at the cost of accuracy. Accuracy should not get hampered. Question number 2, quickly. A hydraulic press has a ram. If you remember, this is how the hydraulic press looks like. This is the ram. This is the plunger. So this is 0.1, let us say this is 0.2. So what we discussed was F1 by A1 is equal to F2 by A2. That is the Pascal law. What is F1? Hydraulic press has a ram of 15 centimeter diameter. It is A2. It is D2. And the plunger of 1.5 centimeter, that is D1. So the question is to find out the force required on the plunger. We need to find out the value of F1. So F1 is equal to F2 into A1 by A2, isn't it? Or we can say F2 into D1 square by D2 square. That is how. And the force required on the plunger, it is required to lift a mass of 1000 kg. So mass of 1000 kg means, if there is a mass of 1000 kg, it means F2 will be equal to 1000 into 10, M into G. It is the force into D1. What is D1? That is 1.5 divided by 15 whole square. That will be the value of F1. So it is 1000 into 10 divided by 100 will be the answer, Newton. Isn't it 100 Newton? Thank you, Umar. Thank you for your beautiful words. Definitely they work as your beautiful words, your encouraging statements definitely brings the motivation and energy to us to bring the concept in the most simple and most easier manner. The answer to this question is again option A. Setupati, not correct. Even though you had given the answer very fast, but your answer was not correct. हमारे सर बोला करते थे कि बेटा जल्दी मत करो वरना देर हो जाएगी. Question number 3 on the screen. Next question on your screen. अगला question. Question number 3 on your screen. Very simple. It is the U-tube manometer which is attached to the air pipeline. Waiting for your answers. Can you see the figure? If anybody is any doubt in understanding the figure or the question, you can just let me know. But I want you to get me the answer. Again, you need to write the pressure equation. In the figure shown, air is contained in the pipe. There is a pipe. This is the pipe. And the air is the fluid in the pipe. Here. And do you know if the fluid is air or a gas, the variation of pressure is very, very less with depth or with height. The variation of pressure is negligible because the pressure variation in a vertical direction is given by rho gh. But if rho is very small, then this value also becomes very, very small, isn't it? So in case of air, in case of gas, the variation of pressure with depth or height is very, very small. We can comfortably ignore to get the correct option in MCQs, isn't it? So even though there is air in the pipe, and can we say the pressure at A is same as the pressure here? Look, this is PA, let us say PA is the pressure. This point will also have the same pressure PA, and approximately this point is also having same PA. Please do let me know if you do not agree. The pressure at this point is also PA. And outside in the right limb of the manometer, the pressure is PATM. Here the pressure is PATM. Outside. This is also air, outside air, and the pressure is PATM. So can we say even though there is the point is 500 mm depth, so the pressure here is PATM. The pressure at this depth is PATM, and according to Pascal law, because the question is asking you to get the value, approximate value. So according to the Pascal law, these 2 points should have the same pressure, isn't it? So PA is almost equal to PATM. Don't you agree? PA is almost equal to PATM. And PATM is, do you know, in case of mercury, in terms of mercury head, it is 760 mm of mercury. That is standard atmospheric pressure 1.013 bar. And in terms of water, it is 10.3 meter of. So the approximate value is option A, because the air density might be different, might vary. There is a slight variation. That is why the approximate value is around 10.1 per meter of water. Absolute. That is the absolute value. PA absolute is PATM. What is PA gauge? That is almost zero. The gauge pressure at A will be zero. The gauge pressure at A will be zero. So no need to solve it. And if you want to write the pressure equation, you can also do that. Look how to write. You can start from point A. This is PA. We are traveling in air. So we are traveling in downward direction. Density of air into G into 200 mm, that is 0.2 meter. This we have reached here. We can jump from here to here. Minus, we are traveling again in air. So density of air into G into 0.5 is equal to PATM. That will give you the absolute. So if you put the density of air almost 1 kg per meter cube, then your answer will be almost similar to option A, isn't it? That is how sometimes the question might look little complicated, but if you are comfortable, if you are confident with your concept, then without solving even you can get the correct answer. I hope it is clear. Can we move to the next one? Question number 4 on the screen. This is very, very beautiful question. I want you to get me the answer. Everyone, please do let me know. This is point A. This is point B. A and B are not shown. What is the correct answer? What is the answer to this question? Is PA equal to PB? Is PA greater than PB? Is PA less than PB, or data is insufficient? What is the correct answer? I want everyone to respond. Don't be mute spectators. It is again differential U-tube manometer. Why it is differential U-tube manometer? Because it can only measure the pressure difference between A and B. It cannot measure the pressure at A separately. It cannot measure the pressure at B separately, because both the limbs are connected to pipe A and pipe B respectively. And yes, the height is same. Yes, this is H. It is mentioned now. Height is same. This is H. This is the manometric fluid. Density of manometric fluid is rho m. This is the manometric fluid. बहुत अच्छा, बहुत खूब. More appropriate. You should always find out more appropriate answer. You might be tempted to select option A, but that is not appropriate. The more appropriate answer is data insufficient. Now try to find out how. Let me call the pressure at A as PA. Let me assume the pressure at B as PB. Now if we write the pressure equation, these 2 points will definitely have same pressure, X and Y, isn't it? X and Y will have same pressure because they are satisfying all the condition of Pascal law. Static fluid in the manometer, point X and Y are lying in the same horizontal plane. point X and Y are joined by the continuous mass of same manometric fluid from the bottom. So they are satisfying each and every condition of Pascal law. So we can start from point where if we write the pressure equation, use datum line method or jumping method, that is purely your choice. We can start from point A. PA is the pressure. We can say this point will also have PA pressure. We are traveling in downward direction, plus we are traveling in the fluid which is there in pipe A. Let me call it as density of fluid as rho A into G into H. That represents Px is equal to Py. To write Py, we can start from point B. Point B is having the pressure Pb. We can jump from B to here because they are also satisfying all the condition of Pascal law. I told you manometer, the limbs of manometer should always be connected normal to the flow, because the manometer is used to measure the static pressure. That is why it must always be kept normal to the flow. We are traveling in downward direction to reach Y. So plus sign will be there according to hydrostatic law. We are traveling in the fluid which is there in flowing in pipe B. Let me call it as density as rho B into G into H. This is Py. So what we can say, Pa minus Pb will be equal to rho B minus rho A into G into H, isn't it? That is the pressure equation. Now it all depends on the density difference, whether Pa will be equal to Pb if rho A is equal to rho B. Pa is greater than Pb if rho B is greater than rho A. Pa will be less than Pb if rho B is less than rho A. So all these possibilities can be there. So that is why all the three options can be correct depending on the fluid which are flowing in pipe A and B. Because they are two separate pipes, so there is a possibility that the fluid might be different. If the situation would have been like this, if there would have been a single pipe, let us say, and if the two limbs of manometer would have been connected between A and B, and if the manometric fluid level would have been same, then definitely Pa and Pb would have been same. Are you getting it? If the manometric fluid deflection would have been 0, then definitely Pa would have been equal to Pb. In that case, the option A would have been correct. But in the given figure, option A is not appropriate. It is option D, which is more correct. The next question is very beautiful. Question number 5. Now let me see who will give me the correct answer for this question. Question number 5 on the screen. Anyone who had given the correct answer for each and every question so far? किसी ने हर क्वेश्चन का जवाब सही दिया? This is very beautiful question. First of all, you should be able to write the pressure equation correctly. All you need to do is to write the pressure equation correctly. If you are comfortable, then no question is difficult. There are so many ways in which question can be framed, but no question, you will not find a single question difficult if you are having strong command in Pascal law and hydrostatic law. That is the need of the hour. So Soban had given the correct answer. Is it correct? So how to write the pressure equation? Let me, first of all, before writing the pressure equation, let us assume the pressure at A and pressure at B. Let me call the pressure at A as PA and let me call the pressure at B as PB. The fluid flowing is water, that is given, and the manometric fluid is mercury, that is also given. A pipe carrying water is attached to a differential gauge. So here up to this point there is water. Water will enter into the limb 1 like this, and in the other limb also water will enter into this limb. And this is the manometric liquid, that is mercury. This is how. And the deflection of manometric liquid is 0.6 meter. Deflection of manometric liquid. Now, how to write the pressure equation? Are you able to write? Let me use jumping method. We will start from point A and we will reach to point B. Our origin is point A and the destination is point B, and we will jump from one point to another in such a way that the points should have the same pressure according to the condition of Pascal law. So the pressure at point A is PA that we have assumed. We are moving in upward direction. We cannot directly jump from A to B because the fluid is flowing. Why we cannot apply Pascal law between A and B directly? Because there is a flowing fluid, and in the flowing fluid we cannot apply the Pascal or hydrostatic law. The Pascal law and hydrostatic law are only valid for static fluid or the fluid which is in hydrostatic condition. That is why we cannot directly jump from A to B. We need to go through the manometer where the fluid is static. So because we are traveling in upward direction, so minus pressure decreases with height. And let me assume this height to be capital H. We require this height. So we are traveling in upward direction and we are traveling in water into G into capital H. We have reached here. Can we jump from here to here? Can we jump? Definitely we can jump because these 2 points are at the same level, static part of static fluid, and they are joined by the continuous mass of water from the top. So the pressure at here will also be same as the pressure here. Can we jump further from here to here? Yes, we can jump again. Why? Because these 2 points are also satisfying all the condition of Pascal law. Same elevation, static fluid, and they are joined by the continuous mass of mercury. Can we jump from here to here? No, that is not possible. Then what we need to do? We need to move in upward direction further minus. Now we are not traveling in water, we are traveling in mercury into G into 0.6. We have reached here. Why I have taken negative sign? Because we are traveling in upward direction. That is why pressure decreases with height. Now we can comfortably jump from here to here because these 2 points are joined by the continuous mass. We are now here. We are traveling in downward direction now. So plus sign will be there, and we are traveling in water only into G into 0.6 plus H, and we have reached to our destination, that is equal to PB. I hope you are comfortable in writing the pressure equation. This minus rho GH and plus rho GH will get cancelled out, and PA minus PB will be equal to density of mercury minus density of water into G into 0.6. That will give you the Pascal. The unit of this expression will be Pascal. That will give you the Pascal, but we are not interested in Pascal because the options are not in Pascal. The options are in pressure head of water. So Pascal can be converted in pressure of head of water by dividing the density of water into G. G and G are getting cancelled out, and we can divide with the density of water. What do you get? So we will get 13.6 minus 1 into 0.6 meter. That is one way. That is 12.6 into 0.6. 12.6 into 0.6. I hope it is clear. That is one approach. Calculate the pressure difference in Pascal and then convert it into meter of water because the options are containing the unit as meter of water. That is one approach. But if you are smart enough to get the pressure equation in terms of water only, because all the options are in terms of water only, better you write the pressure equation in terms of water only. So I will show you how to write. First of all, observe the options given and accordingly write the pressure equation. Let us write the pressure equation in meter of water only. Isn't it? No need to convert. Don't calculate the pressure difference in Pascal and then converting. Better to write the pressure equation in terms of water only. We can assume the pressure at A as PA in terms of water PA. We are traveling in upward direction minus. Then we are traveling in water only, and we want to write the pressure equation in terms of water only. So we are traveling in water, no need to convert. We can say minus H The unit is meter of water minus h. We can jump from here. We can further jump and we are further moving in upward direction minus. Now we are traveling 0.6 meter in mercury. We need to convert it into water. So how to convert the one fluid column into another? By using rho1 h1 is equal to rho2 h. This is the expression which converts one pressure head in one fluid to the pressure head in another fluid, or we can say S1 H1 is equal to S2. Because we are traveling in mercury, so specific gravity of mercury is 13.6 and we are traveling 0.6 meter. Divide by specific gravity of water to convert it into water head. Then we can jump from here to here, and now we are traveling in downward direction plus we are traveling in water, no need to convert. 0.6 plus h is equal to pb. The unit you will be getting as meter of water. I hope it is clear. This is how the conversion should be done. So this minus h getting cancelled out with this plus h. So pa minus pb will be equal to 13.6 into 0.6 minus 0.6 meter of water. You can write the pressure equation in terms of meter of mercury also. If the option would have contained mercury, then accordingly you should have converted every term in terms of pressure head of mercury. I hope it is clear. Anybody is having anything to ask, do let me know. Is this clear to everyone? Is it all clear to everyone? So confusion? S1 H1 is equal to S2 H2. The same pressure which is in the form of one fluid column can be converted into another fluid column. And that is how we can say 760 mm of mercury is same as 10.3 meter of water. You can convert 760 mm of mercury into water column. You will get almost same as 10.3. What is the answer to the next question? Please give it a try. The next question. Very simple. Question number 6. We are halfway now. Pressure gauge is another instrument for measuring the gauge pressure. So there is a tank at 8 meter from the bottom. We are getting 57.4 kilopascal pressure, and at 5 meter we are getting the pressure as 80 kilopascal. So what is the density of the fluid? What is the density of the fluid? What is the answer? So we can write the pressure equation. This is point A, this is point B. So we can write the pressure equation. We can start from A. Then if we write in terms, we can start from A. Then we can say PA is the pressure at A. We are traveling in upward direction minus rho into G into H. What is H? That is 3 meter into 3 is equal to PB. Or we can start from point B. PB plus rho into G into 3 is equal to PA. We know PA, we know PB. G can be taken as 9.81. The only unknown is rho. So what we can say, rho into 9.81 into 3 is equal to PA minus PB, that is 80 minus 57.4 into 10 to the power 3. We need to put all the parameter in their SI units, so then only you will get in kg per meter cube. What is the answer? Are you getting option B? Only Bhavya had given me the answer. What about others? Please give it a try. Please do the calculation and let me know the answer. Both the expressions are correct. Pressure equation. Are you getting option B or not? 768, 767.9 something, isn't it? Or 2, to have your calculation simple, you can have GS10. You can assume GS10. So the nearest option will be correct answer. Very beautiful question. Question number 7. Can you give it a try? Question number 7. Yes, Susoban, 767.9. Now the options are in terms of millimeter of mercury, and I want everyone to write the pressure equation in terms of mercury head. Don't write your pressure equation in Pascal. Do write the pressure equation in terms of mercury head. Then you can save time. In that way, you can save some time. You can use datum line method or jumping method. That is your choice. This is, here it is open to the atmosphere. Here the pressure is PATM. Here it is open to the atmosphere. Here the atmospheric here. It is again simple manometer. So if we write the pressure equation in millimeter of mercury, we can start from point A. It is gas, so there is no variation of pressure in the gas. We can say point C will have the same pressure as PA. So PA, we are at C, we are traveling in downward direction. Which fluid you are talking about? This is water, it is the gas. In the pipe, in the bulb, it is the bulb actually. In the bulb, the fluid is gas, and there is water here, and there is mercury here. It is mercury because density is 13.6 gram per milliliter. So PA, we are at C, we need to move to B, then we are traveling in downward direction, plus we are traveling in water. If we are traveling in water, you need to convert water. We are traveling in water only from C to D. That is 10 plus 5 plus 2, 17 centimeter in water. Or we can say 170 mm in water. So specific gravity of water is 1 into 170 mm. Divide by 13.6 is the specific gravity of mercury. I have used S1, H1 is equal to S2, H2. I have calculated H2. S1 is water, H1 is the water column. S2 is the specific gravity of mercury. We are at D. Can we jump from D to F? Definitely, because these 2 points are just joined by the continuous mass of same static fluid in a horizontal plane. We are at E. It is E, sorry. It is E. We can jump from D to E. Now we need to move in upward direction, minus. And we are traveling in mercury only 2 centimeter, that is 20 mm. So no need to convert. We are at F now. From F, we need to move in upward direction, but we are now traveling in water 5 centimeter. So specific gravity of water is 1 into 50 mm divided by 13.6. And we are at point A, where the pressure is PATM, and PATM is 760 millimeter of mercury. Each and every term should have the same unit, then only they can be added or subtracted. So that is how we get the absolute value of pressure PA. Do the calculation and let me know the answer. Do the calculation and let me know the answer. Are you getting option A or not? Are you guys getting option A? Nearest option is option A. That is the correct answer. Can you write the pressure equation? Can you write the pressure equation in millimeter of glycerin? You can write the pressure equation in any fluid column. In millimeter of glycerin, how to write? You need to do the practice. You can start from point A. You should start from point C. C is having the pressure PA. We are traveling in downward direction. We are traveling in water 1 into 170 mm. Divide by 1.26. Specific gravity of glycerin is 1.26. Glycerin is heavier than water. We are at D. We can jump from D to E. Now we are traveling in upward direction. 20 mm in mercury. 13.6 is the specific gravity. Into 20 mm divided by 1.26. We are at F. We need to move in upward direction. Minus. Now 50 centimeter in water. 1 into 50 mm, sorry. Divided by 1.26. We are at A. A is equal to the atmospheric pressure in terms of mercury, it is 760 mm. In terms of glycerin, it is 13.6 into 760 divided by 1.26. That will give you the absolute pressure in millimeter of glycerin. I hope it is clear. That will give you the answer in millimeter of glycerin. Do not write 760 because you need to convert it into glycerin. You need to convert the atmospheric pressure also in terms of glycerin. I hope it is clear. Is it all fine? Can we move to the next one? Question number 8 on your screen. It is MSQ. This is your assignment question. Again, very simple question. You need to find out which is the minimum pressure and which is maximum pressure. This is your assignment question. Do solve this question at home. And share your answer through the Telegram group or bring your answer in the next class. No, we need to convert. Where is 2 centimeter? We need to convert. I have converted. This is the conversion. For each and every column, we need to convert Susoban. Otherwise, you will get incorrect answer. Okay, you are talking about mercury because we are traveling in mercury only now. Even if you convert 13.6 into 20 mm divided by 13.6 will give you the same value. Right? If you are traveling on in the same fluid in which you are writing the pressure equation, then why to waste time in converting? Numerator will also be S1 and S2 will be same. That is why they will get cancelled out. Yes. The next question, question number 9. Now, who will give me the correct answer for this question? I will wait for the correct answer. Who is going to give me the right answer? ये अच्छा क्वेश्चन है. Question number 9. I'm about to stop in a short while, but do not forget to be part of my day after tomorrow's class. That is the extension of manometry. That will be about the concept of hydrostatic force and buoyancy. Very, very important topic for your GATE and other competitive examination. Ask your civil friends also. दोस्त नहीं है आपके civil engineers. They are not your competitors. So bring the civil engineers also to the platform. If you will bring, each one of you will bring one civil engineer to the platform to this session, then you will get some surprise from my side. You will get the questions, more beautiful questions from my side. I will give you more questions for practice. So Soban had given the answer to the question, that is D. Let us see. Are you able to write the pressure equation? This is called as inverted U-tube manometer. You need to remember two things. One is when to put plus sign, when to put minus sign, when to put plus sign, when to put negative sign. If you are traveling in upward direction, pressure decreases, so negative sign. If you are moving in downward direction in the static fluid, pressure increases, that is why positive sign. The second thing you need to remember is, if you are traveling in fluid 1, then rho 1 will be taken into consideration, rho 1 GH1. And if you are traveling in fluid rho 2, then you should take rho 2. Let me write. Start from point A. PA is the pressure at A, PB is the pressure at B. So these are the points which are having the same pressure. These are the points which are having the same pressure. In the setup shown in figure, assume the specific weight of water is 10 kilonewton per meter cube. What does that mean? It means the density of water is 1000 kg per meter cube and G will be taken as 10 meter per second square. Then only they will become 10 kilonewton, isn't it? G should be taken as 10 meter per second square. So we can start from point A. We are traveling in upward direction, minus. We are traveling in water. The specific gravity, we can say rho into G into H. Rho into G can be written as gamma. that is specific weight into H. So gamma of water into H is 50 mm, 50 centimeter, that is 0.5. We are here, we are traveling in upward direction minus. Now we are traveling in oil. So gamma of oil into 50 centimeter, that is 0.5. We have reached here, we can jump from here to here. Then we are traveling in downward direction plus. Now we are traveling in oil, gamma of oil into 50 plus 50, 100 centimeter is 1 meter is equal to PB. That is the pressure equation. The question is PA minus PB will be equal to gamma of water into 0.5 minus gamma of oil into 1 minus 0.5, isn't it? So gamma of water is 10 kilonewton, that is 10,000 into 0.5 minus what is gamma of oil, that is density into density is 980 into 10, 9800 into 0.5. क्या आ रहा है? What is the correct answer? Gamma of water into 0.5 minus gamma of oil into 0.5 plus gamma of oil into 1 is equal to PB. So PA minus PB is gamma of water into 0.5 गड़बड़ हो गया कुछ? What is the answer? या प्लस आएगा, राइट? दिस अब ठीक है, इधर जाएगा राइट हैंड साइड में, ये जाएगा तो ये नेगेटिव हो जाएगा, ये पॉजिटिव हो जाएगा, तो प्लस गामा ऑफ वाटर, सही तो है, ये तो माइनस से रहेगा. Can you guys hear me? कुछ नेटवर्क में इश्यू है क्या? Are you able to hear me? क्या आएगा? Hello everyone. Can you guys hear me? Am I audible and visible to you all? अभी आई आवाज आई? अभी ठीक है? All right. पीए माइनस पीबी नेगेटिव, क्या क्या गड़बड़ हो रही है? माइनस गामा ऑफ वाटर, ओ सॉरी, ये यहाँ पे गड़बड़ हुई है. हियर इट इज नॉट ऑयल. Pa minus gamma for water into 0.5 minus gamma for oil into 0.5, then it will be gamma for water. यहां गड़बड़ हुई है. Are you able to see it? यहां पे गामा फॉर वाटर होगा, यहां पे गामा फॉर वाटर होगा. फिर से लिखते हैं. Let us write once again. Let us write the equation once again. बस यही गलती हुई है. ये Pa है, ये Pb है. Pa minus gamma for water into 0.5 minus gamma for oil into 0.5. We can jump from here to here, plus gamma for water into 1 is equal to Pb. यही गलती हुई है. तो Pa minus Pb will be equal to gamma for water into 0.5 minus 1 plus gamma for oil into 0.5. ये करना था. ये 10,000 into minus 0.5 plus 9800 into 0.5. That is why we will be getting the negative answer minus, क्या आंसर आएगा? minus 100 Newton per meter square. अब सही है ना? minus 100 Newton per meter square. So the correct answer is option D. So you need to take care of the density of the fluid. You need to take care of the density of the fluid which must be used. That is very, very important. One mistake will give you the incorrect answer. This is again your assignment question. Give it a try. Very simple question. I am about to stop. This is another assignment question. Do solve these questions. The more you solve, the more comfortable you become. And the challenge question is this one. You can take the screenshot for this question. This is the challenge question. And that is all from my side, guys. You can take the screenshot and give this question also a try. We will discuss this question in day after tomorrow's session. And do not forget to be part of the next class, which is all about the hydrostatic force and buoyancy. Very, very important class at 8 p.m. on which day? Friday? Friday on the same channel. That is all from my side, guys. In the last, I would like to thank you all for being part of this session and utilize this free session by practicing the numericals. You keep on doing that. You should continue practicing the numericals. With this note, let me take your leave. Enjoy, take care, have a good night, stay safe, and you should continue your learning. That is very, very important. Thank you, guys. Thank you very much. Thanks a lot. And Jai Hind.